All right, so we have a question. So the question here to see water in a container. So we have a water in a container, just like how we see we have a container here, and then we place this block. After we place this block, but they say original at height. So they did not show here original. Let me draw. Okay, look. So we had a container. As far as I see, we had a container, and then we placed these blocks. But originally the height was 1. So let's draw a little diagram here to show original before we place the container. So let's say this original container before, and this is after the one they have given to us. So before, it was 1 meter, which equal to height, equal to 1 meter. See? So in other way, this is 1 meter here, because this was before. So what happened? 1 meter. So they come, they place a block here. After they place a block, remember, the water is going to be displaced. Gonna have some water here. So there's a principle called Archimedes principle. So Archimedes principle say, look, you see this block here, right? We place here. If you take the weight of this block and measure the weight of this water which is being displaced, is going to be the same weight. So the weight of an object for now of a block, which, okay, let's see here. Okay, got this container here, initial, and then we place a block. When we place a block means the water is going to rise. So the weight of a block equal to the weight of a water displaced. Something like that, water of H2O. So now that's how Archimedes say. So for that case, now they use the Archimedes principle to start to solve this question. But hey, so this H1, so after we place, let's say this is displaced now. So this one is, all of the height is H. You understand what I'm saying? Which is this diagram they gave to us. This is after they have placed a block in a water. So that's why they say this is height, which is the same as that one. Now, so how are we going to solve this? So now let's find the height. You see, let's find what this height here. That's what we're looking for. Because if you look, let's read the question. We didn't even finish reading the question. If a block having the density of that one means the density of the block we have, and place in the water, determine the new level H of the water. New level means you want the all height, which is going to be 1 plus this length here. Let's call it X. Let's just assume it's X. But we want to get this height. So it's going to be equal to 1 plus this X. So what we're going to do, I'm going to say now, since the block is floating in the water, from Archimedes principle, we're going to say now, weight of a block equal to the weight of water displaced by submerged part of the block. Weight. Guys, my handwriting sometimes. Weight of the water. Weight of the water displaced. So we're displaced by submerged part of the block. Submerged part of the block. Now, but hey, they give us some information, which we're going to use now. You're going to see how we're going to use it. But look, what is the weight of the block? What is the weight of the water displaced? But here we know in physics, we say density equal to mass over volume. Okay? Now, if you multiply, it's going to be density times volume equal to mass. But they didn't give us mass. Okay? But also remember, weight equal to mass times gravity. So mass equal to, so this is density, right? So mass divided by G. Mass equal to weight over gravity. So I can replace that weight of gravity, right? So I can come and say this mass, because they give us weight in our equation, right? Okay, let me write it how this. So W equal to mass times gravity. So we divide by G and then divide by G. So this and this cancel. So a mass equal to weight over G. Weight over G. So then this is gonna come here. See? Make sure you write. If in exam you write everything, but I did because my space is not enough. So then I'm gonna say density, volume times instead of say this mass, I'll say what? W over G. W over G. And then I'll multiply G is gonna be density volume times gravity equal to W. Okay. So I'm gonna replace that one and that one right there. Now let's replace. So on the left, remember, on the left is a block, and on the right is the weight of the water displaced. So instead of say weight of the blocks, weight of the block, I'll say equal to density of the blocks times volume of a block times gravity of the, but gravity is the gravity. Okay, so when I say times gravity equal to, for water now. So for water, we're going to say density of water times volume of water displaced times gravity. But gravity is just a gravity. So remember, gravity and gravity is 9.8 for both. So we can cancel. So then, okay, I'm going to write here to have some space. So then I have density of a block times volume of a block equal to density of water displaced times volume of water displaced. Density of a block, I do have this one, 800. Volume of a block, I can get it. How am I going to get volume of a block? Volume of a block equal to the base area times height. What is the base area? The base area have for block equal to, look, the base, of a block, where's the block? They give us somewhere here. The base of a block is 600 millimeter square. So the base area of, okay, let me say here. Let me write it back. So density of a block, which we have, times, what is volume of a block? Volume of a block equal to base area times the height of a block. So volume of a block, make sure you write all this stuff is an exam, right? Equal to, what is it? Area of a block, and then we're going to take down what? Density of the block times volume of a block. But what is volume? Volume means area base, area of a block, base area of a block times height of a block. Equal. And then we come here, we say, okay, now we got density of water, and then we multiply. Volume of it, because volume means area of water, base area of water, times the height of it, water displaced. Look, if we place this water in here, means the base area of a block is going to be the base area of exactly same. Okay, I'm going to say area of a base area of a block equal to the area of base area of a water displaced. Because they place right here, means even the water displaced going to have the same base. Maybe I should do like that, same base. That's why this is going to be the same. So this and this cancel. So area base of a block and area of water displaced is going to be the same. So now density of water, we have height of base area, height of block, we have equal to 600, and then density of water we have, and height of water displaced, which is x. This one here, x, which you're looking for. So then we're gonna say now, we take density of water, density of a block, my apology, times height of a block. And then we divide by density of water equal to the height of water displaced, which equal to x. Density of water we do have, which you can plug it 800. Density of a block, density of block 800 times height of block equal to 600. Density of water 1000. And this is going to give us what? X, or height of water displaced, or equal to x. Plug in the calculator, and this is going to give us 480 millimeter equal to this x, means this height here. Okay, So we're not done with the question. Now we go to the second part of the question, because from the question they say, if you look at the question, they say determine the new level, means you want the whole full height, the new level. So then we're going to say now to get a new level, let's go to step 2. Let's go to step 2. But we know, just come here. Let me just erase something here. Just a minute. Okay, let me erase some things here. Sorry. I'll just erase some stuff here. Okay, so now we say, remember the initial volume of water in a container, initial volume of water in a container equal, let's call V1, initial volume of water in a container, let's call V1, let's say, initially, before the whole placing of the blocks in a container, initial volume of the container equal to the area base of a container, because we need also to involve this container, base of a container, times the height of the container, which is this height of the container. That's what we know initial. But how we get volume? So initial volume of the container we know equal to base area of the container multiplied by the height of the container, which we call what? H1. Let's assume it's H1 equal. See? So this is what. So we say initial volume equal to base area times the height. But what is the base area? We can simply do this. Volume of a container initial before placing anything equal to the base area. What's the base area? Base area equal to base area. You can call area 1. Let's call area 1 times by height. Okay, now let's go for the final. So final volume of water in a container after you have displaced means it's going to be new volume. Final volume of water in a container, which you call, let's call V2. We're going to go to area base of the container. Let's call area of the container 2 times new height of the container. So now for finalizing, then we say, okay, so this can be the second one. But also, now let's go to the block. So the volume of submerged part of the block, volume, let's write it, volume of submerged part of the block after placing a block, let's call it D, equal to the area base of a block, let's call it what? Area base of a block, let's call it A, area base of a block times that length, because say this length we call it X. So we got 3 equations here, V, V2 and V1. Okay, now we want to see the change in volume of water in a container after we have placed. So change in volume of water in a container after placing of a block. Remember, this is going to be equal to the volume of submerged part of the block. So I've made it part of the block, not the whole block, so I'm making it part of the block. So now let's go now. So change, how are you going to get change means you must minus those volumes. So you say V2 minus V1 equal to V. So we know V2, we know V1, and we can get a V. Everything we have, everything we have. Let's plus them. So we say V2, this one. A, C, A to the block times the height. Minus minus. V1 means area, because we want to have area 1 times height. I'm going to do this. I'm going to write again. Nice. I'm going to write so nice. So V2 equal to A2 times H2 minus minus. V1 equal to AC times H1. This one here is equal to that. This is equal to that, and this one is equal to that. And the last one V equal to A area of the block times X. So we have most of the information here. So I can take AC out because it's common. AC is common, so AC out, and I'll be left with it. A2 minus H1 equal to area of a block times X. See? So I want to get H2. So I'm going to divide by AC. I'll divide by AC. And then H1 is going to go over. So H2 equal to area of a block times X over area of a HC, area of a container, and then plus H1. So what we're going to do now, we have all the information. Area of a block, we do have. How are we going to get area of a block? We must take 600 millimeter times 600 millimeter. X, we got it before, which is 480 from the previous, the one we did. Area of a container, we must change this to meter because this is 1.2 meter. So I must say 1, 2 times 1, 2. You understand what I'm saying? And this is gonna give you area of the base. Now, height H1, 1000, because is 1 meter, which you can change it to millimeter, is going to be 1000. So plug all of them, and then after you plug all of them, let's plug it for you. Let me plug it for you so you can see. So we're going to say now H2 equal to, we have all the information. So this is going to be area of a base. We say 600 times 600. Okay, you can say here 600 times 600. And then times X, 480 over AC. What is the AC? 1200 times 1200. And then that's all. So plug in the calculator, and that's going to give you 1120 millimeter. If you want to change to meter, 1120 millimeter. If you want to change this, it's going to be 1.12 what? 1.12 what? Meter. And this is going to be the height of the water in a container. Or you can say this is a new level of the water in a container. So with that being said, man, subscribe, share it with a lot of people, and subscribe. And check the link below for more video. Also check we have a program where we give back to the community, feeding the community. And hey, thanks a lot for your time. Subscribe to my Instagram page, Mntwana_Wabantu, the same name, Mntwana, but _Wabantu. Do not put that 1989 or Academy, no. Mntwana_Wabantu. On Facebook, it's Mntwana Wabantu Academy. And hey, subscribe, leave a comment, tell me the video was helpful to you. Thanks a lot. Peace, and I'm gonna see you soon.